All right, we are into this is in the lab section, of course, week one lab. Sorry, I slurred that out. All right, so I'm going to do this first. We're going to do the endocrine slides. I'm going to click on our outline. This is what I would do in class. And probably will go maybe a little quicker than I do in class because obviously you can just, if you miss something, if you want to go back, you can listen to it again. So I'm going to pull that up, and then I'm also going to pull up this PowerPoint. Now these are actually really good pictures, and I will show you a couple other pictures that are different. On the Padlet, I love that shirt, by the way. I'd love to get that shirt someday. So we're going to start, well, we'll start here first. The endocrine system is actually a pretty complicated system. It's a series of glands that are located throughout the body. And what I should have done, I'll just do it right now. So here's the big giant naked man. Now we're not going to do the hypothalamus, and we're going to do the gonads, the reproductive organs, towards the end of the semester. But the first thing you can tell here is pineal gland, did that in AMP1. The pituitary gland, which is beneath what hangs down, did that also in AMP1. But probably the hard part of the endocrine system is they are located everywhere. You're not really in one part of the body. The organs are scattered throughout, so they go all the way down to the reproductive organs. We are going to cover the adrenal glands, the pancreas, the thymus. Well, actually, the thymus, we don't have a slide for that. We'll talk about that in the lecture. And then you have the thyroid and the parathyroid glands. So they're kind of scattered throughout. They're called ductless, D-U-C-T-L-E-S-S, because they don't have any direct connection to the blood supply. They produce hormones, which are biochemicals, and they release those hormones into the bloodstream, and then they just travel around the body. What you're going to have to do is go through and look at these, know these photos here, which are slide pics, and know the characteristic about it, know what hormones are produced by these glands, and then we'll go from there. So number one, the hypophysis or pituitary gland. Either name. The way medicine works is if this was called the pituitary gland 200 years ago and they decided, oh no, we're going to call it the hypophysis, they keep both names to honor tradition. So the anterior lobe, or what is called the adenohypophysis, you have to know both terms for these. You got to know both terms for those. You do have some cell types that you find in these slides. Now the difference here is in AMP1, we did histology, we did tissue type, we did do some cell types, but tissue type, major group, function, location. These slides are going to have regions. They're going to have structures, cells, all kinds of stuff. So let me show you this first, and I'll show you that we have a special slide for these, and then these are some of the hormones produced by the anterior lobe. So this might be a little dark, and I'll just make it big screen, and I apologize. I don't know why it's so dark, but here's a pointer from the microscope. Now, first few things you want to notice. Here's kind of a little division between the two lobes. This in the front is the anterior lobe. It's got the white spaces. This in the back is the posterior lobe. The posterior lobe is nerve tissue. And there is a cell type there. But the posterior lobe does not produce any hormones. They are produced in the hypothalamus and released from the posterior lobe. But here's the anterior lobe. Now, I'm going to, I think I can just click, I did. Here's a little closer view. This is on the 400. See, there's the posterior lobe. Over here would be the anterior lobe. Couple of things. Now look down here. I'm looking at something kind of blue. Here's kind of a red cell. This is a basophil. This is an acidophil. And you have a few different kinds of basophils in your body. There's actually a white blood cell called a basophil. But those are the two cell types that you find in the anterior lobe. So what I would do in your lab class is I would say, okay, pretend you're taking an exam. If you're asked, what lobe is this? This would be the anterior lobe. If you're asked to name a cell type that's found in the anterior lobe, you can put acidophils or basophils. But I'm going to go back. It should let me. There we go. Here's the 100 view on the 10x. So there's the anterior lobe. There's the posterior lobe. Now, what we're going to do real quick before I exit out of this is a very special slide. It's called our triple stained slide. We only have one. And you can definitely tell here, look at these red colors. Those are acidophils. This is an anterior lobe that's stained to where you can see everything. And then over here, the blue, all of these, and if you see things like that, that's a nucleus. There's a nucleus of an acidophil. These are all basophils, and then these over here would all be acidophils. Pretty simple. So we'll go back. I'm going to make this a little, oh good Lord. This is what caffeine in the middle of the day will do for you. All right, so we did the hypophysis or pituitary gland. Well, we did the front part. The anterior lobe showed you that, acidophils, basophils. Now, like I said, we have a really good slide for that. You can definitely see the reds and blues on that last slide. That's the one that I would use. And what these are all the different hormones associated with the anterior lobe. Growth hormone, overall growth of the body and body cells, prolactin, which is actually a milk-producing hormone. This is adrenal corticotropic hormone, or ACTH. It stimulates the adrenal glands. Thyroid stimulating hormone stimulates the thyroid. And these last two are called gonadotropins. They are follicle stimulating hormone and luteinizing hormone. Those are reproductive hormones. We're going to go over those in lecture. In lab, you'll have to know an example of a hormone, not the function, but an example of the hormone produced by the lobe. The posterior lobe is also called the neural hypophysis. Like I said, it's made of neural tissue. It actually is connected to the hypothalamus where the hormones are produced, and then they are released from the posterior lobe. And there is a cell type, they're called pituocytes. So going back to this, this is the posterior lobe. Those little dots are nuclei of the pituocytes. And anyway, you can't really see cell bodies, but this is all neural tissue. You can see how it's more dense. I'm going to go one more. So over here, more nuclei of pituocytes, and anyway, it's neural tissue. There are two hormones released from the posterior lobe, and I don't believe they are. And oh my goodness! So I'll give you both these now. It's anti-diuretic hormone, or ADH. And the other one is oxytocin. I'll make sure I don't have 4 pints of coffee before I do this. So we have antidiuretic hormone. It's antidiuretic. And just like in class, it just looks wrong, but I'm sure it is. So here's ADH, and then there's oxytocin. Antidiuretic hormone is a hormone that actually makes the kidneys conserve water, and oxytocin is a hormone that causes uterine contractions. All right, we got our first slide out of the way. Now, moving on to the next slide, and I have some pictures to show you based on the mannequin parts, which I will make a video for that. So a follicle. Now, I don't have to, a follicle is called I'll put a little dash here. A thyroid, good grief, thyroid unit. And what it's talking about over here, it's a really good picture. This whole thing, the whole thing, including this part in the middle, is a follicle. Don't really have to identify that. You got to know the parts of a follicle. Colloid, which is this stuff, okay? The stuff in the middle. Colloid is a thick jelly material, and I know I have a C here, but it's the storage form of the thyroid. Good grief. Hormones. I'll get my typing down better. Let's make it pretty like that. So colloid is a thick jelly material, and it actually is. There's two hormones that are stored in it. When the body needs it, it just gets released from here. This is how the thyroid stores hormones. Follicular cells. These, this little ring of cells that goes around that way. Here, those are follicular cells. So they surround, what you can put there is they surround each follicle. So you're talking about this inner ring. Now I know this picture's got a lot of cells, but the inner ring, and I'll show you on our slide in a minute, extrafollicular cells are found between the follicles. Which would be like in this area over here. They're not associated with any kind of colloid or anything. And then there are three hormones produced by the thyroid gland. Thyroxine, triiodothyronin, and the T4 and the T3, the numbers represent the amount of iodine atoms that are found in these two. And then calcitonin, which calcitonin is a calcium hormone. T3 and T4 help control metabolic rate, brain development, a lot of different functions. All right, so that's a thyroid. Now, so we're going to bounce back to our picture. Well, there's the triple stain. So here we are. This is a thyroid gland. Now, what we have in this picture are several follicles. You see, and they're all different sizes. There's a small follicle. There's a larger follicle. There's a bigger even follicle there. The pointer's not really pointing to anything, but what you have to do is get a little closer. Now, this little ring of cells that goes around that way, those are follicular cells. The pink stuff here is colloid. I know in our picture it was yellow, but that's the storage area for T3 and T4. And yes, this whole thing is a follicle, but the pink is colloid. The little ring of cells around it are follicular cells. And what you would do if you were to scan around on your microscope, you would come across areas like this and a little bit up here. These are called extrafollicular cells. They're found between the follicles. They actually produce calcitonin. They're called C cells. I have a lot of different names. Extrafollicular cells is what we're going to use. All right, so that's a thyroid. It's pretty simple. So I'm going to bounce back to our outline. So parathyroid gland. There is one major cell type in a parathyroid gland. They're called chief cells. And parathyroid gland produces parathyroid hormone. Why can't they all be named like that? So I'm going to go back over. Now, on these slides we use, this is a thyroid gland. The actual slide says parathyroid gland because they're so small, and this slide is really good because it's nice and colored. And this, what you would do, I'll just go back. So here you're looking at a thyroid, you're scanning around, and then all of a sudden, boom, you would come across this big mass of cells. That's a parathyroid gland. They're very small. They're found on the back of the thyroid. Some people have 4, some people have 3. All those little dots are nuclei of chief cells. And like I said, the parathyroid gland produces parathyroid hormone. Okay, and I know these have pointers here. You know, on a lab quiz online, you'll have to, pick out what gland is this. Probably have a few more arrows pointing, but that's a parathyroid gland. Now, this should be, I don't know why it's not, it should be big boy print like that. In fact, I'll just, there we go. I made it prettier. The adrenal glands, they sit right on top of the kidneys. We actually have two of these. And adrenal glands are like a lot of organs or glands. They have regions. And this one has two regions and a capsule. By definition, what makes something an organ or a gland is that it has a capsule around it. So I'll show you this, and I have a couple of extra pictures I can show you as well for that. So we're going to go to the next one. Now look, this is before we had the little scanning red objective. This is a slide of an adrenal gland. This outside layer here would be the capsule. And then this all underneath is called the renal cortex. The adrenal cortex. And then if you go down a little further, you see these cells that look like columns going down. Those are the cells of the adrenal cortex. So I'm going to go back. Capsule, right below that, would be the adrenal cortex. If you keep going further to the right here, it would look like this. If you kept going further right, you'd come across the middle part of this gland with this big white area, and it's kind of got a little bit darker red in here. This is the adrenal medulla, and yes, I'll be using these pictures on your quiz, so you don't have to, you can go through and get a good look at all of them. If you were to keep going on the other side, you would come across the cortex area and another capsule. So adrenal capsule, adrenal cortex, and this is called the adrenal medulla. So I know in your outline it just says capsule, cortex, medulla. That's fine. Because if I click on the next one, it's going to be a completely different organ. All right, so that's the adrenal glands. And I can show you, we have some newer slides on the Padlet. We only have a few more of these. Trying to keep these videos short. There's nothing worse than clicking on a video and you see that it's an hour and a half long. So I debated breaking this one up, but I'm going to go ahead and finish this one. We have two slides left. We have the pineal gland and the pancreas. So I'm going to go back out. Here's the pineal gland. Remember that little bitty part of the brain? It's right above what's called the baby's butt, the corpora quadrigemina. It has this purple material that's really hard. It's called brain sand. And here's the hormone produced by the pineal gland. Unfortunately, the slide, oops, I'm a little out of order. The slide doesn't look anything dramatic. So here's a pineal gland. Now just ignore these big white spaces. That's where the slide's coming apart. But there are the cells of the pineal gland. They're called pineal sites. You don't have to know that. It wasn't part of our curriculum. But see the purple over here? That's brain sand. All of that is brain sand. Rocks in your head. Somebody says, hey, you got rocks in your head. You say, you're absolutely anatomically correct. My pineal gland does have calcium carbonate. It's called brain sand. No, but that's what this stuff is. It's calcium carbonate, but if you look it up in the most detailed medical definitions, it's called brain sand. And the pineal gland produces melatonin, which puts you to sleep at night. Last slide of this video, pancreas. Pancreatic islet or islets of Langerhans. You got to know both terms. You got to know both terms for this. Beta cells produce, I'll put a little dash here, a dash. Insulin. Alpha cells produce glucagon. And delta cells produce a hormone called somatostatin. And it's going to be hard for me because I have to write these things out to spell them correctly. But so that's a hormone, and that's a hormone. Once again, we're going to cover the functions in lecture. Insulin is a hormone that lowers blood plasma glucose levels or plasma glucose levels. Glucagon is one that's supposed to raise up plasma glucose levels. Look, you have to know what cell type produces which hormone. Now look, you can't tell in our little slides what's a beta, what's an alpha, and what's a delta. But you can tell, and here it is. Here is a pancreas. All this stuff around it we will cover when we get to digestion, but see this little white area here? It's called an islet of Langerhans, or a pancreatic islet. So it goes all the way around. Now the next picture is super close, which I wouldn't use, but see it in the corner over here, and you can see the margins right there. That is an islet of Langerhans. There are 3 cell types inside here. We're not going to worry about identifying those, but you're going to have to identify like what organ is this found in, and then name this structure. This is an islet of Langerhans, and then know a hormone produced by the pancreas. Okay, and that is the endocrine slides in all their glory. So if you don't mind, when you get ready, the video below this one is going to be over the mannequin structures, which will be really short. All right, thanks for tuning in.
And that's the bottom line, because Stone Cold said so.